Hello everyone, welcome to my guide on C# generics in object-oriented programming. After this 10-minute video, you will be equipped with the knowledge and understanding needed to teach someone else about generics, to answer some basic interview questions pertaining to generics, such as why we need it, what's required to implement, and what is safe code or type-safe code. Most importantly today, you will learn how to implement generics in your programs. In case you're already familiar, here are some timestamps so you can jump around to various parts of this video guide, and these will also be in the description. Before we dive into generics, let's quickly review the core concepts of object-oriented programming. In object-oriented programming, we model our software using objects, which are instances of classes. Classes define the blueprint for objects and define both its data, or attributes, and its behavior, or methods. In object-oriented terms, we use the concept of abstraction to allow us to concentrate on the relevant aspects of the problem necessary for finding a solution, while disregarding the irrelevant elements. Generally, the more of a blueprint your code can look like, the easier it is to reuse, which is the core principle of object-oriented programming, code reusability. Well, what's the use for generics? If we wanted to make easy, reusable code, we must consider what data we're working with. In many scenarios, we work with collections of objects such as lists, stacks, or queues. These collections can store various types of objects, and this is where generics come into play. Generics enable us to write code that works with multiple data types, while maintaining type safety. Type safety is where operations can only be performed on certain data types, which makes sure that your code is secure and doesn't crash when an incorrect or unexpected data type is passed to it. As far as generics go, I feel like the name itself really does allude to its use case. Generics are used to make code more generic and more of a template. Now let's boot up Visual Studio and get practical. These are my methods. I've been using them heavily in most of my projects, if not all of them. I've used them all throughout the year, and I've always been frustrated with how much space and how many lines these take up. If you think about it, these are all doing the same thing. They're reading an int, reading a double, or reading a string. All they're doing is saying something such as, what number would you like? Storing that as a result. Checking that it's an int. Then if it's not, it will ask them again, and then storing the result. These all do the same thing, except this is with a double and this is with a string. Now, if only we could make this more streamlined. If only we could take the abstract version of this, or take the generic version of this, and make a blueprint, such that when we pass a different data type, it will automatically switch between one of these. So, let's do just that. Let's see what the most basic version of this would look like. This is a very stripped down version of this method. You give it a data type, you call it a name, give it a prompt that the user responds to, store the result, display the prompt, if it's not, try again, return the result. So, our main problem is that our methods are dealing with different data types but are doing very similar things. The solution to our problem is generics. Before we get started in generics, you're going to see this a lot. You'll see two angled brackets with a T in the middle. This parameter will appear a lot in generics, so it's important that you understand what it is straight away to stop you from getting confused later. T is a type parameter, and it can be used for field names, return types, method parameters, and delegates. A delegate represents references to a method with a parameter list and return type. In actuality, T doesn't have to be T at all. You are free to name it whatever helps you remember. Personally, I keep mine as T. It's more conventional and follows typical coding practices, which means it's easier for a stranger, or a coworker, or a tutor in the help hub to read your code and identify what you're trying to make happen. You might be confused and think this is something you've never seen or never plan to use, and this is just going to throw a monkey wrench in the mix. Well, don't worry, you actually have seen this before. Lists. Lists are generic types. They have these angled brackets, and when you type in them, it changes what the list will store. Here's an example of a list that stores an integer. As you can probably imagine, it would be very inconvenient to have 7 different lists, one for each different data type, having a list int, and a list double, and a list decimal. It would be quite frustrating. So having something you can easily interchange and reuse throughout your code, all on the same method, really does help with reusability. Now, let's implement this in our code, so our code can be just as reusable as lists. Going back to Visual Studio, we can see I've created a read value method. All it does is the same as these. You can see I've specified it as a generic method by including these angled brackets, including the t here for its data type, and then the rest is just as usual. I've given it a prompt that it has to display into the console. The result from the prompt is stored as a t data type and is set to default. The console writes the prompt, going into the while loop. If the data type that it's been passed and tried to store in result cannot change into the data type that was specified when the method was originally called, then it will throw either a format or an invalid cast exception. This will display an error message and then go back to the while loop and get it to try again, just like what we were doing over here. Once it's successful, it will return the result. Let's take a look at an example of us using our read value code in practice. Over here, I've specified that I would like the integer to be the received value, and I'm storing that in a variable called num. Over here, the same with decimal, and then the same with string. Let's see what happens if we don't put an integer. It tells us to go back, try again. Let's try with a decimal, try again, and now let's try with a integer. And it works. Now what about with a decimal data type? Gets me to try again, and then when I put a decimal, what do you know? What about a string? Strings are a bit different in that strings can hold a number, but it cannot be used in a calculation. So that is why the string did accept and print the data type. For my second example on generics, I'm going to show you how generic classes and constructors can work. This class works with a given value. It stores that value, it uses the read value obviously, and then in the constructor it takes a value that is of the t data type. It then stores a given value in response to input a value, and that is stored into the value data type. If the value is the same as the value that is given when the constructor is called, the value returns that it's equal, and if it's not, it says have a nice day. But either way, it is storing that value in underscore value, which in turn gets stored into the value property. We can see this in practice in my main class, where I have created two new generic class instances, and I have inputted the values of 12 and test into the constructor. You can see when I go into the input a value section of the constructor, which is here, this is the value that is actually being stored in value. And if it is the same value, so it was 12, it tells me that the values are equal. And if I input a random button mashing of an input, I get have a nice day, because they're not equal. But either way, these are both stored in underscore value, which also means they're stored in value. The most important takeaway from this example is that whether we're using strings or integers, whether we're inputting 12 or test, either way, we're using the same method, the same constructor. We're using the same thing, inputting two different data types, and we're getting two of the same results. That right there is what generics is all about. It increases code reusability because we didn't have to have a separate one for a test that's a string. We didn't have to have a different one for an integer. We used the exact same constructor, the exact same method, the exact same code, and we got two different data types to work. You might think, how can I change a specific object's behavior if I'm just going to be accepting all data types? Well, this is where generics constraints come into play. Constraints allow certain type-based changes that you can make. You can limit the amount of types used with your generics. For instance, you could say where t is a class, do this, or where t is this object, do this. This allows you to limit the amount of options that your generics can take, and it specifically allows you to change the behavior of certain elements or certain data types that could be passed to your generic method. What are the pros and cons of generics? Well, generics facilitates code reusability. which in turn reduces the volume and minimizes code duplication that is in your program. Generics improves code readability. It's quite easy to read a program that has something such as read value, and then when the value is passed to it, it reads that specific data type. In my opinion, that's much easier than having a read string, read int, read double. The cons are that if you use too many generics and overdo method generalization, it can be very hard to understand what your program does from an outsider's perspective. The short and fast. The too long didn't watch the I've got an assignment due tomorrow and I just need to understand how generics works. Well, generics are just type placeholders, and they can be used to make methods more versatile, flexible, and reusable. They're specified by adding these angled brackets, where when you call the method, you would swap t with your specified data type. To summarize, C# generics are a powerful feature of object-oriented programming that enable you to write more flexible, efficient, and versatile code. They allow you to work with different data types while ensuring type safety, and as you continue and explore C# programming, consider incorporating generics into your programming toolkit. Thank you for your time, and I hope you learned something.